Morning students, in the previous classes we studied about how a conductor behaves in an electric field and what is a dielectric and how it behaves in an electric field. We studied that in a dielectric slab, electric field due to polarization is developed, and this is the last class of your second chapter, that is the last class of electrostatics. So whatever concepts we have discussed in this chapter, that is uploaded in your importance as different videos, and all these videos that is available in our YouTube channel, Concepts of Physics by CBSE. All these videos are uploaded in YouTube channel also. So those who are not able to see our videos properly in importance, they can subscribe to our YouTube channel. So you assume a capacitor. The area of each plate is A. The distance between the plates is D. And if air is the medium between the plates, how much capacitance is there? We proved in the previous chapter that the expression for the capacitance is A epsilon naught by D. Area of the plates, absolute permittivity, and distance between the plates. That was the capacitor. You know, in capacitor there is a positive plate and a negative plate. Magnitude of the positive charge, magnitude of the negative charge are equal. The distance between the plates is D. The uniform electric field between the plates E naught is equal to sigma by epsilon naught, and that is acting from positive plate to negative plate. In this situation, we are introducing a dielectric slab of thickness T, which is bigger. Definitely T must be smaller. Then only we can introduce this dielectric slab in between the plates of this capacitor. As the dielectric slab is introduced between the plates, suddenly which phenomena is happening? There is polarization. The stretching of the atoms, molecules, due to the influence of electric field. And because of that polarization, there is an opposite small electric field developed from positive side of the dielectric slab to the negative side of the slab. Otherwise, opposite to the applied electric field E naught, and that small electric field is called electric field due to polarization. Because of these two fields, the net electric field inside the dielectric slab, ER, is equal to E naught by E naught minus EP. ER is called reduced electric field. There are two electric fields, applied electric field E naught and reduced electric field ER. Now listen carefully. Where this ER is existing, where it is existing? It is very clear, it is existing inside the dielectric slab. And what is the thickness of that slab in the diagram? It is T. So for the thickness T, how much electric field is there? There is electric field ER. And what is that ER? That is E naught minus EP. Now, in this diagram you see, there is a left side gap and right side gap. This left side gap and right side gap together, how much it is there? It is called D minus T. So for the thickness D minus T, how much electric field is existing? That means this gap and this gap together, how much electric field is existing in this space? The electric field existing here is E naught itself. So your reduced field that is existing only inside the slab, and outside the slab your applied electric field sigma by epsilon naught, which is equal to E naught, that is existing. And you are familiar with this equation, relation between E and V. E is equal to minus dV by dr, or E is equal to dV by dr in magnitude. Now what is the meaning of this equation? Electric field is equal to potential gradient and negative potential gradient. You know the meaning of negative sign. So if you cross multiply this, E into dr is called dV. So if you multiply E and dr, you are getting dV. What is the meaning of this? If you multiply electric field with its thickness, you will get electric potential. See the concept clearly, very clearly. E is equal to dV by dr. So E into dr is called dV. Electric field, you have to multiply with its corresponding thickness where it is existing. Then what will you get? You will get electric potential. You apply this concept to this diagram or this table. This table is the summary what is happening in this case. If a dielectric slab is placed in an electric field, you can see how much potential difference is between the plates of the capacitor now. Potential difference V is equal to, in this diagram, how much V is existing between the plates. V is equal to, electric potential is equal to, you have to multiply electric field with its thickness. That means you have to multiply ER with T. See, ER is existing for T thickness and E naught is existing for how much thickness? D minus T thickness. So if you multiply these two and take the sum, you are getting the total potential difference between the plates. And instead of AR, previous class already I told you, ER, E naught by ER is called K. So instead of ER, you can write E naught by K. ER is equal to E naught by K. So replace here. So V is equal to E naught by dielectric constant T plus E naught D minus T. And what is E naught? How much electric field is there in between the plates? You see, E naught is equal to sigma by epsilon naught. Many times we repeated the same. So instead of E naught, you can write sigma by epsilon naught. And what is sigma? Lambda sigma. Sigma is Q by A. So Q by A epsilon naught. So instead of this E naught, you can write A by Q by A epsilon naught. So this equation becomes V is equal to E naught, you can take as common factor. Then what is there inside the bracket? There is T by K plus D minus C. And instead of E naught, what you can write? Instead of E naught, you can write A epsilon naught sigma by epsilon naught, that is Q by A epsilon naught. E naught is sigma by epsilon naught and sigma is charge by area. So instead of E naught, you can write Q by A epsilon naught bracket T by K. So we can write like this. First you write D. D minus T plus T by K. We arrange from that. Now, what is arrange? You have to find how much capacitance is there after the introduction of dielectric law. Capacitance after the introduction of dielectric law. C with dielectric law. How much? That is what is required. You know, capacitance is equal to charge upon potential difference, Q by V. From this expression, very clearly you can write what is Q by V. Q is going to the right side, Q is already there on the right side, V is going to the right side. Take the other terms to the left side. So your answer will be Q by V from this expression is A epsilon naught D minus T plus T by K. So I am taking T as common factor. So it will be 1 minus 1 by K. This is number 2. You compare equation number 1 and equation number 2. You see, in equation number 1, C air, A epsilon naught by D. In equation number 2, C with the dielectric law, A epsilon naught, same A epsilon naught, D minus T into something. If you compare 1 and 2, you can see that their numerators are same, A epsilon naught. Just see the denominator. Which denominator is more? Here denominator is D and here D minus something. Definitely D minus something is bigger than D. Otherwise, the denominator of say 2 is smaller. Denominator is smaller, meaning answer is bigger. So from 1 and 2, which is greater? C dash or C air? Which is greater? 1 is greater. So C dash is greater than C. So the capacitance with dielectric law in between the plates of the capacitor is greater than capacitance with air as the medium between the plates. That is what we proved. So this is again a very important CBSE question. If you refer the previous question paper, you can see either dielectric law or conducting law. Now this question is different from the previous one. The previous case it was dielectric law. Now what you are doing, you are introducing a conducting law, where in between the plates of a charged capacitor, what is happening to the capacitance? Again, capacitance increases. So in which medium the capacitance is minimum? If you introduce dielectric law, then also capacitance increases. If you introduce dielectric conducting law, then also capacitance increase. So the capacitance is minimum if air is the medium between the plates. So today we are going to study if you introduce a conducting slab of thickness T is introduced in between the plates of a capacitor with a D as the separation between the plates. Positive plate, negative plate, the separation between the plates is D. You are introducing a conducting slab of thickness T where T is smaller than D. Then only you can introduce. T must be small. Then only it will become in between the plates. That is introduced. If a conductor is placed in an electric field, already we studied, the electric field inside the conductor is 0. So for the thickness T, how much electric field is there? How much electric field is there? For the thickness T, the electric field is 0. And for the remaining thickness means D minus T. D minus T stands for left side gap as well as right side gap together. So the remaining D minus T thickness, how much electric field is existing? It is your E naught itself, and that E naught is equal to sigma by epsilon naught, and sigma by epsilon naught is Q by A epsilon naught. This is the behavior. Now in the previous case, if it is a dielectric slab, the 0 is not there. Instead of 0, ER is there. So the only difference, and this is same. So the only difference is for the first line. For the thickness T, if it is a dielectric slab, there is ER, and if it is a conducting slab, there is 0. Now the answer is very simple. In the previous derivation, wherever you are written ER, you replace all your ER with 0. So instead of ER, what is happening now? Now it is 0. So you repeat the previous derivation and replace your ER with 0, you will get the conclusion. So you can start with the capacitor. If air is the medium, the capacitance is A epsilon naught by D. That is your equation number 1, previous step. Now electric field into thickness, because E into dr is equal to dV. Electric field multiplied with the corresponding thickness, that will give you potential difference. So 0 into T. Previous case it was ER into T. Now it is 0 into T. See, instead of ER, you have to write 0. See, 0 multiplied with T plus E0 multiplied with T minus T. That will give you potential difference between the plates of the capacitor after the introduction of conducting slab. That's the only difference, this 0. Now the answer is very simple now, because 0 into 2 is 0. So only this much part is left. So your V is equal to E naught D minus T. And what is E naught? E naught is sigma by epsilon naught. And what is sigma by epsilon naught? Q by A epsilon naught. So instead of E naught, you can write Q by A epsilon naught into D minus T in the numerator. See? Q by A epsilon naught for E naught and D minus T. Now you know Q upon V is called capacitance. So capacitance after the introduction of conducting slab, Q by V. From this equation it is very clear. Q by V is equal to A epsilon naught divided by D minus T. That is your equation number 2. Equation number 1, capacitance with air as the medium. Equation number 2, capacitance with the conducting slab as the medium between the plates. Now it is very simple thing. If you compare 1 and 2, you can see that their numerators are same, A epsilon naught, and here denominator is D in 1, and 2 it is D minus 2. So it is very clear that D minus T is smaller than D. So denominator of equation number 2 is smaller. Therefore, equation number 2 is bigger than equation number 1. So capacitance with the conducting slab greater than capacitance with air. So the summary is this one. If you introduce dielectric slab or if you introduce conducting slab, in both cases your capacitance increases. Now you can think, if your D is equal to T, what is going to happen? D is equal to T, what is the meaning? D and T are equal means the conducting slab and the plates of the capacitor, they are in contact with each other. Exactly in contact with each other. That is the meaning if D is equal to T. So this is positive plate and this is your negative plate. and T is equal to D. So exactly in contact. Otherwise, this conducting slab and the plates of the capacitor together behaves like a single conductor. Isn't it? There is touching between them. So this arrangement is behaving like a single conductor. You know what is a capacitor? If a charged plate is placed near to an earthed uncharged conductor, this arrangement is called a capacitor. So in this situation, and capacitor, you know, that is an arrangement for storing large quantity of charge. So if you are supplying charge to this plate, positive plate, what will happen? Can you tell what will happen? Because the system behaves like an earthed system. See, it's an earthed conductor. It behaves like an earthed conductor. So whatever charge you are giving here, that will be directly flowing towards earth. Or the arrangement goes on accepting the charge. How much charge it can accept? It will accept any quantity of charge, infinity. It goes on accepting infinite charge. But actually it is not accepting. It is just like a pot whose bottom part is open, broken. So if you add water, what will happen? The same water that will flow to earth. There is no accumulation of water inside this pot. The same thing is happening here. Whatever charge you are supplying to the positive plate, that will be directly flowing to the earth because their system behaves like a conductor. Or it behaves, it goes on accepting infinite charge, or its capacitance becomes infinity. Just now we proved C dash is equal to A epsilon naught by D minus T. Is it not? So if D is equal to T, what is happening? D is equal to T, then your C dash becomes A epsilon naught by 0. Because D and T are equal. Something by 0 is called infinity. So C dash becomes infinity. Capacitance becomes infinity if conducting slab is introduced in between its plates.